Laws of exponents and solving exponent equations. Before we go through some typical IB exam questions, let's recap the laws of exponents. So if you have x to the 6 times x to the 3, that's the same as x to the 6 plus 3, which is x to the 9. Same sort of rule for division. If you have x to the 6 divided by x to the 3, that's the same as x to the 6 minus 3, which is equal to x cubed. Third one, if you have an exponent raised to another exponent, so x squared raised to the power of 3, you multiply the exponent. So that is x to the 2 times 3, which is x to the 6. For the fourth one, if you have x times y cubed, you just split them up. So that's x cubed, y cubed. Same sort of thing for division. If you have x divided by y raised to the power of 4, that's the same as x to the power of 4 divided by y to the power of 4. X to the power of 0. Anything to the power of 0 is always 1. X to a negative power, so x to the power of minus 3 is the same as 1 over x to the power of 3. So you take it from the numerator and it becomes the denominator and it changes to positive. And fractional, so if you have x to the power of 5 over 3, the numerator is the number you multiply to the power of x by, and the denominator is the root. So x to the 5 over 3 is x to the 5 cube rooted. Sometimes it's easier to write x to the 5 over 3 as the cube root of x raised to the power of 5. Depending if you're asked to find a numerical value, sometimes that version is easier. So this is a typical IB exam question. Find the values of x when 27 raised to the power of x plus 2 equals 1/9 raised to the power of 2x plus 4. The first thing you got to do when in any of these sort of questions is to make the bases, so 27 and 1/9, be the same base. 27 is equal to 3 cubed, and 1/9 is equal to 1 over 3 squared, which is equal to 3 to the power of minus 2. I can now rewrite the equation in the same base. So 27x to the minus 2 becomes 3 cubed to the power of x plus 2 equals 1/9 becomes 3 to the power of minus 2 to the power of 2x plus 4. Because it is one power raised to another power, we can just multiply out. So we get 3 to the power of 3x plus 6 equals 3 to the power of minus 4x minus 2 times 4 is 8. Minus 8, sorry. So let's rewrite that. That's minus 8. Now, because the bases are the same, I can write 3x plus 6 is equal to minus 4x minus, keep getting that wrong, minus 8. So therefore 7x equals minus 14, so x equals minus 2. So another example is find the values of x when 25 raised to the power of x squared minus 2x equals 1 over 125 raised to the power of 4x plus 2. Again, the first thing is to get the bases the same. So 25 is equal to 5 squared, and 1 over 125 is equal to 1 over 5 cubed, which is equal to 5 to the power of minus 3. I can now rearrange the equations in the same base. So I get 5 squared raised to the power of x squared minus 2x is equal to 5 to the minus 3 raised to the power of 4x plus 2. This is a power raised to a power, so multiply out. So you get 5 to the power of 2x squared minus 4x is equal to 5 to the power of minus 12x minus 6. Because they are now in the same base, I can just write 2x squared minus 4x is equal to minus 12x minus 6. Therefore, 2x squared plus 8x plus 6 is equal to 0. I can now divide through by 2 to make it easier. So I've got x squared plus 4x plus 3 equals 0. So therefore I've got x plus 3, x plus 1 is equal to 0. So x equals minus 3, or x equals minus 1. A more difficult question is something like, solve the equation 9 to the power of x plus 2 times 3 to the power of x plus 1 equals 1. Again, we need to make sure all the bases are the same. 9 to the power of x is the same as 3 squared to the power of x, which can also be written as 3 to the power of x squared. And 3 to the power of x plus 1 is equal to 3 to the power of x times 3. Rewriting the equation as 3 to the power of x squared plus 3 times 2 is 6 times 3 to the power of x equals 1, which is equal to 3 to the power of x all squared plus 6 times 3 to the power of x minus 1 equals 0. This is actually a quadratic. I'm going to let y equal 3 to the power of x. Now I'm going to substitute y for 3 to the power of x. So I get y squared plus 6y minus 1 equals 0. This quadratic will not factorise, so I will have to use the quadratic formula to solve. So I get y is equal to minus 6 plus or minus the square root of 6 squared minus 4 times 1 times minus 1 all over 2 times minus 1. So y is minus 3 plus or minus root 10. Because x must be positive, the only value is y equals minus 3 plus root 10. Now I'm going to substitute back in for y, so 3 to the power of x is equal to minus 3 plus root 10. I can solve by taking logs of both sides. I'm going to use log base 3, so therefore I've got log base 3, 3 to the power of x is equal to log to the base 3 of minus 3 plus root 10. Log to the 3 to the power of x is just x, so therefore x is equal to log to the base 3 minus 3 plus root 10.